Given a 10 by 10 by 10 array of zeros, set ijk equal to 1 if all of the following hold true. I is odd, j is even, and k is prime. In other words, set these elements to 1. Okay, here's the solution that I came up with. Let's break it down. So the I indices that we're interested in are going to be the odd indices. So those are going to be 1, 3, 5, 7, and 9. J is going to be the even indices, 0, 2, 4, 6, and 8. And K will be the prime indices, so those will be 2, 3, 5, and 7. Now, the specific elements that we want are actually going to be the Cartesian product of these three arrays. So in other words, the combination of these three. So 1, 0, 2, 1, 0, 3, 1, 0, 5, and so on. In total, it's going to be 5 times 5 times 4, so 100 elements that we want to update to 1. So if we try to do something like Chewy square brackets I comma j comma k equals 1, this actually will give us an error, and it's not at all what we want. What this is attempting to do is it's attempting to set element 1, 0, 2 as 1, then 3, 2, 3 as 1, 5, 4, 5, 7, 6, 7, and then lastly element 9, 8, and then this is missing a k index, so that's where you get the error. But besides the fact that it errors, it's really trying to just update 5 values instead of 100 values. So what we want, like I said, is going to be the Cartesian product of these guys. Now, one way you can do that is with broadcasting. So if I do I square brackets colon comma none, this turns my 5 by array into a 5 by 1 by 1 array. And then if I do j square brackets none colon none, this turns into a 1 by 5 by 1 array. And k square brackets none comma colon becomes a 1 by 1 by 4 array. So NumPy will broadcast these index arrays into the following 5 by 5 by 4 index arrays. And you can imagine that they get zipped together into the following tuples, which pick out the exact elements that we want to update and set equal to 1. Now, there's a shorthand way to do this, and that's with the function np.ix underscore. And so if I say np.ix underscore and I pass in a sequence of 1D arrays like I, j, and k, it returns what's called an open mesh, which is exactly what we've done here. So then all I have to do is say Chewy square brackets np.ix underscore ijk, close square brackets, and set that equal to 1. And this statement here is equivalent to this statement here. So that's just a shorthand way to subset an array when you have 1D arrays and you want to sort of get the Cartesian product of these to select out specific elements.